Hello and welcome to this quick video tutorial on the nth term. You might find questions like this in your exam which ask you to write an expression in terms of n for a sequence. I'm going to show you a quick method that I use for finding the nth term of a sequence. What I need to do first off is I need to start by finding the term-to-term rule. That's what happens between each of the terms in the sequence. Well, I can see that actually between each of the numbers in the sequence we've got a +3. I'm adding 3 each time. The thing that I'm adding each time or taking away each time or whatever is going on in between each term of the sequence goes in front of n. And then to work out whether or not I've got anything that goes on the end of my expression, I like to look at the difference and using the first term in the sequence see, well, how do I get from a +3 to a +5? Well, I would have to add 2. So the term for the nth term for this sequence is 3n plus 2. We're then asked hence. Now this word hence, it basically means, looking at what's gone on before it. In other words, this question here. Find the 25th term. So finding the 25th term of this sequence. Now in this expression, n is the term number. The position of each of the numbers in the sequence. So I want to find the 25th number in that sequence. Now I could add 3 each time until I get to the 25th term, but that might take me a little while. What I can do is I can substitute in 25 for n. 3 lots of n, which is 25, and then add 2. 3 times 25 for 75, adding 2 for 77. So the 25th number in this sequence would be 77. You might also be asked questions like this. Is 57 a term in the sequence? Well, looking at the sequence 4, 12, 20, 28, 36, I could go about it and finding the nth term and then using an algebraic way to work this out. But there is something I notice about this sequence, and that is that it's only got even numbers in it. Now, because the term-to-term rule, or the thing that is happening in between each of these things, is a +8, I know that if I add an even number to an even number, I will always get an even number. So I can actually quite confidently say, without doing any sort of algebra or anything like that, that no, 57 is not a term. Because it is odd. And then we can sort of flesh that up a bit and out a bit and say, all of the other numbers in the sequence are even. There is an algebraic way that you can go about doing this, which I can show you, but in this case you don't need to use it, but you might need to. I can find the nth term, the term-to-term rule, a +8, that goes in front of n. I then look at this 8 and say, well, how do I get from a +8 to a +4? And that is, I take away 4. So my nth term for this particular sequence would be 8n minus 4. I can set that to 57 and then solve this simple equation. If I've got a -4 on this side, I need to add 4 to both sides. 8n is equal to 61, and then divide by 8 to find n. Now, 61 divided by 8 is not going to give me a nice number. It's going to give me 7 and a bit. Okay? I can't have a bit of a term, so therefore 57 is not a term in the sequence. It would only be a term in the sequence if, when we do this division, we get a whole number or a whole integer.